I'm Matteo, so another software architect in the Open Data Hub team. Has anybody of you ever heard about observability? Okay, so a couple of programs crashed in production. Any one of you knows about logs? And no? Okay. Well, we'll see what we're talking about. So first of all, we will talk about the problem. So the Open Data Hub has been and is evolving even more into a distributed system where we have dozens, but I'd like to say hundreds of microservices interoperating with each other. And while we, of course, use logging, which is the basic of observability, it has become really hard to tell if the system is running as it should be, tell if an incident happens, because we only know when logging are emitted and the incident is already happened. And we also started to having a limited visibility into the system, how it behaves, how it performs, because distributed systems are very nice, are the top niche, the peak of the computer science until you have to manage one. So what is observability? Observability is the ability to understand the internal state of a system, examining the outputs. As we said, we have logging, which is the basic. So you have what is happening inside your system, and then we have metrics, which basically tells how this is happening. Is it happening as it should? Do we have some bottlenecks? How many requests per second are coming in? How many requests per second are being processed? And so on and so on. And then we have something which is very niche, but is the most important for the distributed system, which is tracing. Because tracing is the ability of telling how the system is behaving as a whole system, not just microservices doing their job, but who is calling which microservices, which triggers what other pipeline, and so on. So trace is who initiated it, I would call it. Well, as we said, logs alone offers a really useful insight about the system, but it's somehow scope limited. Like, for example, this log here, we know that a program couldn't unmarshal a message. And while this is very useful because we know that something broke, we don't know where it broke. This leads us to what we want, because we don't only want to catch errors, but we want also to be proactive into the system management. We want to set up alerts to detect unexpected behavior or restarts, or even the reduction of the throughput of the system, and all of this information we have to scrape from somewhere. About the implementation, the solution we implemented, we choose basically 5 components, which of course is Kubernetes, which is the run environment in which all the Open Data Hub works. Then we choose Prometheus as a metric server, which is de facto the standard for all the enterprises in the world. It's mature and very widely used. We choose Grafana Tempo from the Grafana Labs ecosystem for tracing. Of course, we had and we still have an Elasticsearch server for logs, and to visualize everything in nice and usable dashboards, we use Grafana. Let's talk about the 2 second citizens of observability, because we all know what logs are. But what are metrics? So metrics are basically the performance of the system as a whole or single microservices. And we do collect those metrics using Prometheus with a pull mechanism where every system, every service and components in this infrastructure has to expose an endpoint which Prometheus can call and get metrics about the system. Fortunately, we use Kubernetes, which already expose a control plane with cluster nodes and namespace level metrics, so we know how the cluster of Kubernetes is performing out of the box without doing anything. But for all other components we installed, like RabbitMQ for messaging, MongoDB as storage, all the microservices, we had to do some work. Could be activating a flag, like in RabbitMQ, fortunately, or having to deploy some services which are tasked with scraping and transforming the metrics so that Prometheus can understand them, like for the case of MongoDB. Tracing is even more work to do, because tracing needs to be pushed from every component performing tasks in the infrastructure to the tracing server, which is Tempo. The power of tracing is that you know who called you, and you want to let who you are calling that it's you calling. So you have basically to develop and integrate middlewares in every input and middlewares in every output, so that you can propagate de facto the trace and the spans ID, so that we can know the whole flow of our request, and all of this has to be done at application level. So we develop a Go SDK which abstracts and hides this whole complexity behind an easy-to-use SDK, but still it has been a little bit challenging. And what about metrics for microservices? Because we talk about the metrics of Kubernetes and MongoDB or RabbitMQ. Well, we exploit actually a component of the Grafana ecosystem, which is called Metrics Generator, the Grafana Tempo Metrics Generator, which is a very nice program which transforms trace into metrics. Basically, you ingest the trace inside this component, he does its magic and outputs some metrics. So we fortunately didn't have to instrument all our microservices, which are dozens. The list which Clemens showed before is not even half of what we expect to have in production. And instead of having each of these microservices become a very big service because they had to expose an endpoint to Prometheus to scrape them, we decided to exploit Metrics Generator, just emit trace and let Metrics Generator do the heavy lift for us. Metrics Generator is a component of the Tempo ecosystem, which generates red metrics from traces. Red stands for request rate, so how many requests per second do the service evade, yeah. The error rate of the service and the duration of each request. So it's pretty much everything you need to monitor a microservice like ours, where data comes in, gets transformed, and goes out. Once we have the whole observability setup, which is not only logs, we could do some magic. Some magic is, for example, correlation between logs and metrics, logs and trace, where we see that having a trace here, we can just click the button here in Grafana and jump to the logs specifically for that request. This is very important where you have pipelines like ours, which last for 4, 5, 6, 7 microservices, one after the other, and then you get an error at the end. So who generated that error? With the correlation, you can collect all the logs for that specific request, examine what happened in the system as a whole during that request, and then spot the problem, for example. A high overview of the implementation is this thing where we have the 3-node cluster Kubernetes with Prometheus here scraping both Kubernetes and the core components, microservicing, emitting logs in Elasticsearch, emitting trace to Tempo makes this magic with metrics generator and then push to Prometheus, and then we have Grafana, which can visualize everything in one single place. What changed since we introduced observability? Well, we gained control again on our infrastructure because we know that if something goes wrong, we are confident that we can spot the problem. We can also set up targeted alerts, and something which is nice, not really important, but nice. We also started to give to our infrastructure a shape, which is quite nice because having hundreds of microservices somewhere is different from seeing them actually working as a system. If any of you want, plans, or need to start this journey of implementing observability because someone wants to create the next gen Power BI and you want to have a lot of microservices and program running as an ecosystem, I would suggest to start with logs, of course, because logs are the base of knowing what's happening. Adding trace once the system scales, because you don't really need trace if your whole logic is in a monolithic Java application, even though you could actually create internal trace, but that's not really useful. And then generate only the metrics you need when you need. It's not, if you have thousands of metrics, doesn't mean you know about your system. You have to know which metrics are important for your particular use case. That's why I suggest to use tools like Tempo Metrics Generator for the start, and then when you have particular SLO or SLI, you can start building your own metrics, and then of course tune later as you use your system. Final thought about our journey into the observability is that working with distributed system, as I said at the start, could become very overwhelming. Even though you are a senior or you have 30 years of experience, it's still a distributed system. And when you have programs, calling programs, things can quickly spiral out of control because you lose control of who is calling who and in which way. And observability brings you back in control and gives you somehow an overview of what you're doing and what the system you created is doing. Thank you.